Hello everyone. Today I will be talking about a question based on Great Circle course. This came in the month of January 2020. Ship made phase 1 navigation. The question is a ship on a Great Circle track from 47 degree 24 minutes south, 0006 degree 12 minutes east to 18 degree 36 minutes south, 063 degree 18 minutes east. Find the GC distance, initial course, position of vertex, and latitude where the GC track cuts 10 degree east longitude. Starting point is A, there is 47 degree 24 minutes south, and longitude is 006 degree 12 minutes east. In B is 18 degree 36 minutes south, and B's longitude is 063 18 minutes east. Delay between A and B is 28 degree 14 minutes and D long. Between A and B is 57 degree 06 minutes east. So B lies north of A and east of A. There is a northeast. B lies to the north of A and east of A. So we know that PA is equal to 90 minus latitude of A, there is 90 degree minus 47 degree 24 minute is equal to 42 degree 36 minute. PB is equal to 90 degree minus lat of B is equal to 90 degree minus 18 degree 36 minute is equal to 71 degree 24 minute. D long between A and B, there is D long, this is angle A and B, between A and B, that is P is equal to 57 degree 06 minute. So this is south latitude. I have taken the south pole. A is here, B is here, and this is the GC track. So to find GC distance using cosine formula, cos of P is equal to cos of P is equal to cos of AB, cos of AB minus cos of PA into cos of PB divided by sine of PA into sine of PB. So cos of AB, cos of AB is equal to cos of P into sine PA into sine PB plus cos of PA into cos of PB. Substitute the respective values. So cos 57 degree 06 minute into sine of 42 degree 36 minute into sine of 71 degree 24 minute plus cos of 42 degree 36 minute into cos of 71 degree 24 minute. So GC distance AB is equal to 54 degree 19.3 into 60. There is 3259.3 nautical miles. That is from A to B is 3259.3 nautical miles. So now we'll find out the initial course. Courses are measured clockwise from true north to ship's head and expressed in three-figure notation. So now to find the initial course, cos of A is equal to cos of PB minus cos of PA into cos of AB divided by sine of PA into sine of AB. We have already calculated PB, PA and AB, so we just put the values and simplify, and we got angle A is 101 degree 34.7. There is this internet angle. When we calculate, we get this internet angle. Same thing goes for finite course. When we calculate, we got this angle. So courses are measured clockwise from true north to ship's head and expressed in three-figure notation. So this small one is the ship's figure. So for A, this is the direction of true north is here. So measure from starting from true north and up to the ship's head. So initial course will be 180 degree minus this angle, 180 degree minus A. So this will be 180 degree minus 101 degree 34.7, there is 70 degree 25.3. So initial cos is equal to 078.4 degree true. Though the question is not as final course, I have just calculated to find out the final cos. We apply cosine formula. Cos of B is equal to cos of PA into cos of PB into cos of AB divided by sine of PB into sine of AB. So just put the respective values and simplify, and we get angle B as 44 degree 23.9. There is this angle. So for B, the direction of true north will be this one. So starting from true north, and we measure up to ship's head. So this angle and this angle are same, diagonally opposite angle. So angle B is equal to final cos, there is 044.4 degree true. Now the question is also asking in initial cos and after that position of vertex, and also latitude where the GC track cuts 10 degree is longitude. So what is a vertex? The vertex of a great circle is the point at which the great circle is nearest to the geographical pole. There is the point at which it receives the maximum latitude. The angle at the vertex between the GC track and the meridian of vertex is 90 degree and forms special right angle spherical triangle that can be solved by using Napier's rule. And to determine whether the vertex will be outside or inside. So when both angles A and B are acute, that is less than 90 degree, the vertex lies within the triangle. That is, if this internal angle A is also acute, that is less than 90 degree, and if angle B also less than 90 degree, the vertex will lie within A and B. The vertex will lie within this A and B. Okay, this is this point, and if one angle is acute and other is obtuse, the vertex lies outside the GC track, that is outside the triangle and on the side of obtuse angle. Suppose this here in this case, angle A is obtuse, there is more than 90 degree, 101 degree 34.7. B is acute. So vertex will lie on the side, vertex will lie outside the triangle and on the side of obtuse angle. Vertex will lie outside the triangle and on the side of obtuse. Here angle A is obtuse, more than 90 degree, and it will lie outside the triangle and on the side of obtuse angle. So vertex will be here, somewhere here. So for this finding out vertex, we have taken Papa Bravo Victor, this triangle. Papa Bravo Victor, this triangle. So P B V, there is Papa Bravo Victor. In this triangle, angle B is 90 degree. PA we have already calculated, 90 degree minus that of A is equal to 90 degree minus 47 degree 24 is equal to 42 degree 36 minute. And PB, there is 90 degree minus that of B is equal to 90 degree minus 18 degree 36 minute. There is 71 degree 24 minute. B, the final cos we have calculated above, and that is 44 degree 23.9. So we apply Napier's rule. There is sine of PB, sine of Papa Victor is equal to cos of 90 minus PB, cos of 90 minus PB into cos of 90 minus B. So cos of 90 minus PB. Cos of 90 degree minus PB is 71 degree 24 minute. 90 degree minus 71 degree 24 minute will be 18 degree 36 minute. Cos of 90 minus PB is 18 degree 36 minute into cos of 90 minus B, that is 90 minus 44 degree 23.9 will be 45 degree 36.1. So you simplify PB, we got 41 degree 32.2. So latitude of V, latitude of Victor, that will be 90 degree minus 41 degree 32.2, that is 48 degree 27.8 south. We go the latitude of this. Now we'll find out this angle P. So again we apply Nepier's rule. Sine of 90 minus P, sine of 90 minus P is equal to tan of P, tan of PV into tan of 90 minus PV, tan of 90 minus PV. So PB we have calculated here, tan of 41 degree 32.2 into tan of 90 minus PB. 90 minus PB, 90 minus PB is 18 degree 36 minute. So 90 minus P is equal to 17 degree 20.7. So P is, there is this angle is equal to, this angle is equal to 72 degree 39.3. So now we know the longitude of Bravo B, that is 06 degree 18 minute east. And this angle is 72 degree 39.3 west. So in order to find out longitude of vertex, B is here. So if we start coming out like this on more to the west, B is 63 degree 18 minute east, and if we come like this, here somewhere here, it will be 0 degree. There is, if you come from here 63 degree, then it will be 0 here, and the remaining, there is 72 degree 39.3 minus 63 degree 18 minute, there is around 9 degree 21.3. There is it will go in the west side. So 009 degree 21.3 west. Longitude of B is going to 06 degree 18 minute east minus this one, we are going from here to here on westerly direction. So longitude of B is equal to 009 degree 21.3 minute west. Finally, position of vertex is equal to 48 degree 27.8 minutes south, 009 degree 21.3 west. Now the last part of the question is latitude where the GC track cuts 10 degree east longitude. Now we have already calculated the position of vertex. That is this latitude and longitude also we have calculated. Now this L, this is the 10 degree longitude, and we have to find out the latitude where this GC track cuts. This point we need to find out the latitude where this GC track is cutting this point. So this triangle Papa Victor Lima PVL. So I have taken out this triangle here, Papa Victor Lima, to find out the latitude where the GC track cuts 10 degree longitude. Longitude of vertex we already know. We have already calculated 009 degree 21.3 minute west. And the longitude of required position L. That is, this is the longitude given in the 10 degree east. So D long between Victor and Lima, that is 19 degree 21.3 degree, this angle. So we'll apply Nepier's rule here because at vertex 90 degrees form. So PB we write here, then BL here, adjacent to the 90 degree, then 90 minus L, 90 minus L, 90 minus PL, 90 minus PL, then 90 minus P, 90 minus P. So applying Napier's rule in triangle PVL, Papa Victor Lima. So sine of 90 minus P, sine of 90 minus P is equal to tan of 90 minus PL into tan of PV. Tan of 90 minus PL taken out on the left hand side, and the remaining sine 90 minus P divided by tan of PV. So sine 90 minus P, this angle 19 degree 21.3, 90 degree minus 19 degree 21.3 divided by tan of PB. PB we have already calculated, 41 degree 32.2. So sine 70 degree 38.7 divided by tan 41 degree 32.2. So tan of 90 minus PL, that is latitude of L, is equal to 90 minus PL, that is 46 degree 48.2 south. The latitude where the GC track cuts 10 degree longitude is 46 degree 48.2 south. Thank you for watching this video. Hope you have understood the sum.